Hello everyone, I am your instructor, Wang Shengda. Today, we will study the characteristics of polymer structure. Through this lesson, you will master the characteristics of polymer structure. You will learn the levels of polymer structure. You will be able to determine which level a particular polymer structure belongs to. You will establish the logical relationship between structure and properties. The physical properties of any material are a response to the movement of its microscopic particles. Polymers are also a material. By studying polymer structure, we can understand the essence of molecular and intermolecular interactions in polymers. We will establish the intrinsic connection between structure and properties. In other words, the microscopic structure of a polymer determines the properties of the polymer material. The properties of polymer materials can reflect the microscopic structure of polymers. Learning about the structure of polymers is essential for synthesizing polymers with required properties, or for modifying the properties of existing polymers, which is of significant theoretical and practical importance. First, let's study what structural differences exist between polymers and small molecules. Compared to small molecules, polymers have the following characteristics. First, the molecules are huge. Polymers have long chain structures. They consist of a large number of structural units, typically on the order of 10 to the third to 10 to the fifth units. These structural units can be one type, or several types. The shape of polymers, formed by the polymerization of small molecules, can be linear, branched, cross-linked, etc. Second, flexibility of polymer chains. Polymer chains are connected by covalent bonds, forming long-chain macromolecules with certain internal rotational freedom. They can move relatively freely. This allows the polymer backbone to bend, conferring flexibility to the chain. Due to molecular thermal motion, the shape of the flexible chain can continuously change. Third, heterogeneity of polymer structure. Current synthesis techniques cannot ensure that every polymer chain has the same length. It is also impossible to ensure that the bonding order, spatial configuration, sequence distribution, branching degree, cross-linking degree, and other structural parameters of the structural units in each polymer chain are identical. Even under the same synthesis conditions, it is impossible to obtain a completely uniform product. Fourth, complexity of polymer aggregate structure. Polymer chains contain many structural units. The interactions between structural units significantly affect their aggregate structure and physical properties. Due to different molecular arrangements, polymers can form amorphous, crystalline, liquid crystalline, and other states. Depending on the degree of crystallinity, crystalline polymers can be low crystalline, semi-crystalline, or highly crystalline. Fifth, the structure of the polymer network is more complex. During processing, polymer materials require the addition of fillers, pigments, various additives, etc. Or two or more types of polymers are blended together. These additives interact with the polymer and between different polymers, forming a network structure with various shapes and more complex structure. The network structure is also an important factor determining the performance of polymer materials. The above 5 structural factors all affect the final polymer properties, making the performance of polymers vary widely. Due to the large size of polymers, their structure is also divided into 4 levels. The chain structure includes the first and second levels. First, the short-range structure, also known as the primary structure, which includes constitution and configuration. Constitution includes the chemical composition of structural units, branching, cross-linking, and group types, etc. Configuration includes linkage isomerism, optical isomerism, geometric isomerism, etc. The short-range structure studies the relationship between one or several structural units within a polymer. The second-level structure is the long-range structure. It is also known as the secondary structure. It mainly involves conformation, which is the shape of the polymer in space. This includes extended chains, folded chains, helical chains, random coils, etc. The aggregate structure includes the third and fourth levels. The third level is the tertiary structure. This includes amorphous structure, crystalline structure, oriented structure, liquid crystalline structure, etc. The tertiary structure studies the relationship between the same type of polymers. The fourth level is the textural structure. It is also known as the higher level structure. This includes polymer alloys and composite materials. It studies the relationships between different types of polymers and between polymers and other materials. In this lesson, we studied the characteristics of polymer structure. Huge molecules, chains with flexibility, structural heterogeneity, structural complexity. The hierarchy of polymer structure comprises 4 levels.